What is matter? Anything that occupies space and has mass is nothing but matter. For example, the book you are holding it, that is also matter, because when you place the book, it occupies some space. When you lift the book, you'll feel some mass. The same way water also. It is having definite volume. Understood? And definite. It occupies some space and definite volume. Even air. We can't observe the air, but you fill the balloon with air and weigh it. Understood? Flatted and deflated balloon, if you weigh it, so that you can feel the difference. Understood? It's nothing but even air is also having mass. Understood? Yes?
Yes, ma'am.
Next. What is matter made up of? What is matter made up of? According to Dalton, a scientist of 19th century, named this small piece of iron the iron atom. But previously, in 18th century itself, Democritus and Eutychus, two scientists, they are Indian scientists, Indian philosophists. Okay. So these two, what we can say? Sorry, they are Greek philosophers. They are the Greek philosophers. Democritus and Eutychus are Greek philosophers. Those two has given that when we break the matter into a small pieces, when the stage comes, the smallest piece which cannot be divided further, that small piece is considered as atom. But they have given atom, but they have not given any proof statement. What they said is correct, but there is no much proof about it. So 18th century this proportion has arisen, but in 19th century, John Dalton elaborately worked on this doctrine, and he gave some postulates. These postulates are nothing but proved statements, and they were proved correct. And these, even though at 19th century we are learning it, that means they are proved and they are correct. Understand? Name this small piece of iron the iron atom. So for example, here three metals are there. One is copper, iron and silver. When you break the copper consists of copper atom only. When you break atom in the sense which cannot be divided further, it's like indivisible, which means end. Further at particular stage, which we cannot divide it further. That smallest piece is considered as atom. So copper consists of copper atoms. Iron consists of iron atoms. Gold consists of gold atoms. That small piece of atom gives the entire properties of the element. The full bar. No other properties it shows. Only the properties of that particular bar of metal.
Yes, ma'am, because all the atoms are only of gold, so it's an element. Has the same atom.
All the atoms are having all the atoms are identical within the element. But gold atom is different from copper atom. Copper atom is different from silver. And silver is different from gold and copper. Understood? Yes. So matter is made up of how the wall is made up of bricks, how the body is made up of cells. At the same way, the matter is made up of atoms. Next. Next slide. Is it visible?
Yeah, ma'am, it's visible.
Yeah, thank you. So here we can take the examples example. So we have discussed about atomicity. We have discussed about atomicity. Yes.
Yes, ma'am, we have discussed about it.
Atomicity is nothing but number of atoms present in a molecule or a compound. Okay. Let me explain once again. There should not be any doubt here. So, atom is the, sorry.
Ma'am, all of these are elements only, right?
No. All these are molecules, not elements. Elements means quantity elements we are having now in periodic table without interacting. Without interacting with other elements, the pure elements which are present in the periodic table, they are considered as elements. So we are having 118 elements at present. Okay. So the smallest piece of element is atom. What is a compound? Compound is a combination of two or more different elements. Example of element we can give hydrogen, oxygen, nitrogen, helium. The simple elements, the natural elements which are present in the periodic table, they are considered as elements. They are very pure. They doesn't react until they reacts with other elements. They are considered as pure. Understand? So when we see the compound smallest pieces, smallest unit is molecule. Example, H2. Hydrogen, 2 atoms of hydrogen, 1 atom of oxygen, CSO4, copper sulfate is also considered as copper. Why? Because this copper and sulfate reacts and bonds chemically to form a compound. So compound is also considered as pure. Ma'am, you said that element is pure. Why? Because if we break a single element, we'll get the same atoms. But when we consider compound is a combination of two or more different elements. But why are you saying it is considered as pure? No, compound is considered as pure. Why? Because here, though it is a combination of oxygen, it is a combination of copper, sulfur, oxygen, or copper and sulfate, whatever. Okay, but all the elements combining chemically and they show single property. Shows single property. Okay, so one more compound I can give the example like HCl. HCl means acid. Here hydrogen is there, here hydrogen is there. This hydrogen shows the property of water. This hydrogen shows the properties of acid. That means when they are combining with other element, they are showing entirely one property. Here also chlorine acts like acid. Here copper acting like salt. Here oxygen is acting like neutral compound. That is water. Understood? Yes or no? So in the atmosphere, like 118 elements, this is like an example of periodic table. You can see it's nothing but a sketch of periodic table, like a external skeletal view of the periodic table. So if we go with this hydrogen in the atmosphere, single hydrogen won't be present. So the single hydrogen always ability to combine with the other hydrogen. Understood? So definitely if one hydrogen is over there, definitely it attracts with the other hydrogen. They combine chemically without any force of attraction. That means external force of attraction. They themselves combines, and in the atmosphere, the hydrogen is available only in the form of H2 molecule only. H2 molecule only. Here nitrogen also N2 only. Oxygen O2. Here the bond is nothing but covalent bond. It's not ionic bond. When it breaks, there is no formation of charge. This you have studied in the higher class. Okay. Only covalent bond is formed between two hydrogens, two oxygens, two nitrogens, two fluorines, two chlorines, two bromines, two iodines, or any other elements. Understood? But there are elements which doesn't require any bond formation with other elements or its own elements, like helium, neon, argon, krypton, xenon, radon. All these are the inert gas elements. They are gaseous state. They are gaseous at the room temperature, and even though they will be like monoatomic. Monoatomic means the number of atoms present in it. H2 hydrogen gas. What is the atomicity of hydrogen gas? 2. Oxygen gas is there, O2. What is the atomicity of oxygen gas? 2. Means 2 atoms are present, number of atoms. Here, copper sulfate is there. What is the atomicity of copper sulfate compound? 1 copper, 1 sulfate, 4 oxygens. Total atomicity is 6. Understood, children?
Ma'am.
Okay. So I want to take sulfuric acid, H2SO4. 2 hydrogens, 1 sulfur, and 4 oxygens. So total atomicity is 7. Here phosphorus is there. Phosphorus in the atmosphere, single phosphorus wants to combine with 4 other phosphorus. So the atomicity of phosphorus is? Atomicity of phosphorus is?
No. 5.
5 in the picture itself it's there, no dear.
Ma'am, 5 phosphorus, right?
Yes, 5 also. 5 also we can say. Like phosphorus 5 also available, phosphorus 4 also available. But here the phosphorus having ability to form with 4 other phosphorus, like P4. 4 is the atomicity of phosphorus. Sulfur 8. Crown-shaped structure. It is called crown-shaped structure. You can see the yellow balls, crown-shaped structure. The atomicity of sulfur in general is 8. Atomicity is nothing but number of atoms present in a molecule. Atomicity is nothing but number of atoms present in a molecule. Any doubts?
Ma'am, I didn't understand about this 2, 4, 8 and all.
That is electronic configuration, dear. This is not related to this concept actually. If you want me to explain, I definitely explain at the last.
Ma'am, can I explain in the class? After the class, 5 minutes?
Yeah, after that, after this completion, I have 5 minutes before I just explain. Okay, Lena? Okay.